So this video will teach you how to calculate the limits of rational functions. Okay, let's move on to the first type. So the first example is if the degree is larger in the numerator. So I'll explain what this means. So that means we're taking the limit as x tends to infinity of a number. Let's start with a sub 0, x to the nth, plus a sub 1, x to the n minus 1, all the way until plus dot 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 plus, let me just think about this for a second, a sub n minus 2 over times x to the first plus a sub n minus 1. All of this over b sub 0 times x to the nth plus b sub 1 times x to the n m minus 1 plus dot 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 all the way until b sub n minus 2 x plus b sub n minus 2. So if we want to take the limit of this, the first thing we'll do is we'll divide both the numerator and the denominator by times 1 over, basically dividing by 1 over x to the nth. 1 over x to the nth. And by the way, and just so we know, n is greater than m, since the degree is larger in the numerator. So when we multiply all this, we get limit of, as x tends to infinity, of, what is this, a sub 0 plus a sub 1 over x plus all the way until plus, I'll just go with this one, a sub n minus 1 over x to the nth. Now, when we divide this one, we'll get b0 times x to the nth over x to the nth all the way until b sub n minus 2 over x to the nth. Now, if you don't notice, all of this stuff tends to 0, a sub 1 over x all the way until a sub n minus 1 over x to the nth. And since n is greater than m, everything in the bottom tends to 0. So you get limit of x to the x as it tends to infinity of a sub 0 over 0. The technical way of writing this is to say that this limit does not exist. However, sometimes it is more useful to say that the limit is infinity. But if you're ever writing where you need one answer and one answer only, such as in a competition or in a, or in a test, you must always write does not exist for this type of limit. Okay, now let us move on to the next type of limit. So now we're dealing with if the limit is greater in the denominator. So I'm not really going to explain this to you because it's really not useful. You can prove this for yourself, and I highly recommend you do so. But if you just want to know the formula, here's what it is. So the limit at x tends to infinity of a sub 0 of x to the nth plus all the way until a sub n minus 1 over b over 0 times x to the nth plus dot 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 all the way until b to the n minus 1. Given that m is greater than n, this always equals to 0. Always, always, always. Now, let us move to the final example. Now, if the degrees are equal in the numerator and the denominator, as in if the limit as x tends to infinity of a sub 0 x to the nth plus all the way until plus a to the n minus 1 over b sub 0 over x to the nth plus dot 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 plus b to the n minus 1. What you have left is equal to a sub 0 over b sub 0. So basically you're just dividing the leading coefficient, the numerator, by the leading coefficient in the denominator. Highly recommend you to prove it, but I'm not going to do it in the video. Now let's move on to some problems. Now we have 3 problems. So the limit at x tends to infinity of 3x squared minus 4x plus 2 over 7x squared minus 9. So since the degrees of the leading term of the numerator and the denominator are equal, 2 is equal to the 2, then we can say that this is equal to the leading coefficient of this term, 3, divided by the leading coefficient of this term, 7. This is equal to 3 over 7. So now, let's go to the second term. So now, since we know that the leading coefficient of the numerator, 3, is greater than the leading coefficient of the denominator, which is basically 1. So we know that this limit does not exist. However, sometimes it is more useful to say that this could potentially be infinity, but also remember that this does not always hold true, and that the formal answer is does not exist. And if it's negative on the top, for instance, if this is a negative, then it would tend to negative infinity, not to positive infinity. Okay? Now, finally, let's look at the last term. Since the leading coefficient is greater in the bottom than in the top, 3 to 2, we know that this limit is equal to 0. So if you found that interesting, be sure to subscribe and like the video. And if you want to, here's 2 more videos that you can watch. Thank you, and see you later.